I hope you're all having a great day. I'm Mr. Ish. Thank you for joining me. Our survey of these graphs of trigonometric functions will be completed with this, the cotangent function. Recently we've looked at the tangent, now let's look at the cotangent. The graphs are pretty much the same except for a few differences. If you look at an xy plane and you make your relative points, you can go by pi's, by 180s. You have a pi and then you have a 2 pi. Here you'll have a minus pi, and now here you have a minus 2 pi, and then squeeze in these 90-degree angles. You can put a positive 1, minus 1 over there. Now think about the cotan in terms of a cosine over a sine. Anything which was in terms of the sine 0 or an x-intercept on the sine graph, now you'll end up with a 0 in the denominator, and you wouldn't want that. The zeros, the pi's, the 2 pi's and their negative counterparts all zeroed out the sine function. So anywhere you have these, you'll end up with a 0 in the denominator. It'll be undefined. So those areas are where a vertical asymptote will develop, because that's how you would indicate an undefined. So you see your y-axis is indeed a vertical asymptote because it's a 0. You got your minus pi and minus 2 pi. Now let's erase this. Think about where the cosine is zeroed out. On its own, the cosine is zeroed out at the 90-degree multiples, whether they're positive or minus, 90, 270, minus 90, minus 270. So wherever you have those, you'll zero out your numerator, but the function will become 0. It won't become defined. So that's exactly where you'll see these x-intercepts of your cotangent function, right over here. Now you got to determine the direction of the curve. Very roughly, if the tangent goes like this, from left to right, your curve is going upwards. The cotangent goes downwards from left to right. You see that everything goes down in terms of the range, so remember that. And when you look at this, you squeeze in your cotangent in between your asymptotes. Now remember, in terms of these 45-degree angles, the cotangent and the tangent are always values of 1. Tan of 45 is a 1, cotan of 45 is a 1. Same for 135, 225, 315, except the signs will change, positive and minus based on the quadrants. Cotangent and tangent are positive in the first and third quadrant, but they're negative in the second and the fourth. Anyhow, the cotangent function will look something like this, like that, right over here. Remember the tan function, I'm just drawing a single wave of the tan function from minus pi over 2 to pi over 2, where the vertical asymptotes were. It looked like this, but this right here would correspond to this y-axis center point right over here. But you see how the tangent is quite different. Anyhow, let's look at the domain and the range. The range is easy. It's minus infinity to positive infinity. The up and the down, or the down to up extent of this function is minus infinity to positive infinity. The domain is a little more tricky. Think about it. X can be an element of all real numbers, except x cannot equal to what? What are these? These are the areas of your asymptotes. Well, the first asymptote is this right here, your y-axis, which is x equals 0, and then every asymptote after there is 180 degrees away. You can say x is not equal to 0 plus or minus pi n, and that right there would be it. Those would be indicative of your vertical asymptotes, but those are areas where your x is not defined with regards to the domain of the cotangent, and that right there, the graph of the cotangent, and you should know it. Before we end this video, because the purpose here was the graph determination, just remember this in terms of the period, the size of a single wave. The size of a single wave for cosine and sine is always 2 pi. Each wave is 360 degrees, but the same applies for secant and cosecant. It's again 2 pi, even though the wave is split. Remember how the wave was split? One portion was here, one here, like that. For the secant and the cosecant, you see that it's still a single 2 pi, even though there's a break in it. But for the tan, the period is just a pi, 180 degrees, and likewise for cotangent, the period is pi, 180 degrees. And that right there is exactly what you see over here. Each wave, 0 to pi, it's 180 degrees, pi to 360, 180 degrees. Everywhere you see the tangent and the cotangent are always 180 degrees long. The single wavelet is 180 in terms of its period. Always remember that these ones here are 360 degrees long. That's about all I want to present to you in this video. Thank you for watching. Have a good day. Bye.